Hey guys, welcome to Learn QA and Alert channel. In this lesson, we will try to understand the applications of geometry in percentage. So generally, you can have the questions like the silence or increases or decreases by some percentage. How does the areas and volumes will change? So those are the typical applications. Let's see the first question. I will try to explain in various formats. You would try to figure out which method you feel comfortable. So here you have a square and the silent is increases by 20%, right? If we increase the silent by 20%, the area will change. What is the percentage change in area is a question. If I take the silent as A, then area is A into A, which is A square. I'm telling 3-4 methods, guys. This is one traditional model you can see in most of the books. That's why I'm discussing. And if the silent is increased by 20%, the new side is 20% more than A. So 20% more than means 120% of A. 120% means 1.2 into A. Even this is also 1.2 into A. What is new area, friends? 1.2 into A, 1.2 into A, which is 1.44 into A square. And we discussed the small observation. Percentage change is nothing but change in value by base value into 100. So change in value means increase or decrease. From A squared, it increases to 1.44. So the increase in value is 0.44 into A squared. And that increase happened from initial area A squared. So denominator is A squared. So this A square gets cancelled. 0.44 into 100 is 44% increase. If the value increase, we'll call it as percentage increase. If the value decreases, we'll call it as percentage decrease. What are the other ways of learning this then? We know that one specific formula that area is A into A. Friends, if the silence are directly proportional to the area, if they alter in the same proportion, areas has to change. I mean, if area increases, silence increases. If silence decreases, area also decreases. Vice versa situation for it. We don't know what is initial area. Let us say 100% is there. There are two dimensions, two variables in the question. So we need to increase or decrease by 2 times for a 2D figure. If it is a 3D figure, we need to do it for 3 times. So silent increases by 20%. So what is the new area? 120%. So one dimension is done. But there is second dimension which again increases by 20%. So 20% of 120 is 24. 10% 12, 20% 24 increases. It becomes 144%. What is the net increase, guys? The net increase in the area is 44%. Any other way to solve, guys? Any other way to solve? Yes. In the one of the previous lecture, we discussed a formula when there is 2 percentage changes of A% and then B%. Then we discussed a net percentage change. Net percentage change, that is A plus B plus A into B by 100. Here, if they increase, take positive sign. If they decrease, take negative sign. Here, dimensions are increasing, right? So square, both dimensions are same. A and B, both are same, equal to 20%. So you can apply whenever 2 variables are in the question. Now A is 20%. In fact, B are the same 20%. AB 20 into 20 by 100. So 0, 0, 0, 0 cancel. So 2 into 2, 4, 24 plus 20, 44%. As you got positive sign, it is percentage increase. Simple, right? So you can use this formula whenever there are 2 variables. But I don't think this is useful for 3 variables model. Then there is one more model called successive multiplying factors model. So if anybody missed my previous video on successive increases or decreases, I request you to see this video. It will give very good information. So we don't know initial area. Let us say 100% is there. If the silent increase by 20%, new area is 120%. But there is second dimension in the square formula. Again 20% increase, it becomes 120%. So 0, 0, 0, 0, 0, 0 gets cancelled. 0, 0 gets cancelled. 12 into 12, 144% is the later area. Friends, we started with 100 and we ended with 144. What is net increase in area? 44% increase. And this is the beauty of aptitude. It's all about our thought process, However you solve, you'll get the answer, but right approaches are very important, guys. Right? So let us go for the next question. Now you have a rectangle in which the length is increased by 30%, breadth is decreases by 20%. Let us say area is proportional to L into B. Now you can use that A plus B plus AB by 100, but I generally go for 100% model because with 3 variables also you can get it. Anyhow, we will do another 3 methods, right? So 100% is area, length increased by 30%, so area becomes 130%, and then breadth decreases by 20%. So what is 10% of 130? 13. 20%, 26 decreases from 130, 104%. So net increase in area is 4%. Or if you want to go by the formula method, A plus B plus A into B by 100 method, the net percentage change. What is that? Here length means A plus 30, breadth means B minus 20, right? Because that is decreasing. Now A into B by 100. So 0, 0, 0, 0 cancel. 30 minus 20 is 10, and 3 to minus 2 minus 6. So this is 4%. Positive means increase. There is one more model, successive percentage changes model. What is that? If 100% area is there, initially area increased by 30%. So what is area? 130%, guys. And breadth decreased by 20%. So new area is 80%. Increase means plus, decrease means minus. So 100, these two zeros cancel. 100 and cancel. 13 is a 104%. So what is net increase, guys? There is a 4% increase. So in this way, you can do in various methods, right? Let's go for the next application. Okay, now let us go for a simple method. Now radius is increased by 10%. We know that area of circle is pi r square. So pi is a constant which doesn't play any role. Then area is proportional to radius into radius. So let us consider area is 100%. When radius increases by 10%, it becomes 110. And again 10% increase because there is second radius. So 10% of 110 is 11. If 11 increases, 121%. So net increase is a 21% increase. Of course, you can use that A plus B plus A into B by 100. So 10 plus 10, 20. So 100, 100 cancel plus 1. So this is 21. Anyone you can use. Even that percentage, successive percentage model also you can use that. But let us go for the next question. You can try all of them and move on. Now we have a fantastic 3D question. Let's see. If the radius of the cylinder increases by 20% and height decreases by 33 1/3%, then find the percentage change in the volume. Friends, we know that volume of cylinder is pi into r square into h. So pi is a constant which cannot affect in increasing or decreasing the volume. Only variables plays the role. So volume is proportional to radius is r into h. R square is r into h. Now you cannot apply that A plus B plus AB by 100 because this is applicable for only 2 variables, but now 3 variables are there in the formula, right? So let us go for successive percentages and then formula. We have that multiplying factors as well. If I say the initial volume is 100%, friends. Now radius is increases by 20%. So what is the new volume after the first radius increases? 120%. But there is second radius in the formula. Again 20% increase. What is 10% of 120? 12. 20% double. 24. If 24 increases, this becomes 144%. And height is decreases by 33 1/3. Friends, what is fraction equivalent to percentage of 33 1/3? 1/3. So what is 1/3 of 144? 3 equals 4 times 12. 2 remainder. 3 8 is 24. So 1/3 of 144 is 48 decreases. So from 144, if 48 decreases, this becomes 96%, right? So what is the net change? The net change is a 4% decrease. Or else if you want to go for the multiplying factors model, let's see that. So 100% is the volume. Radius increases by 20%. It becomes 120%, friends. And there is second radius in the formula. Again, 20% increase, 120%. Friends, if height is decreases by 1/3, 33 1/3 is 1/3, right? If 1/3 decreases, 2/3 of the value is present, right? So 2/3 of the value is present. So this 100 cancel. This 100, 2 zeros cancel. So 3 goes 4 times, 2 4s are 8, 8 12s are 96% is the final volume. Now friends, what is the difference? This is initial, this is final. The difference is 4% decrease. Anyhow, you can get the same answer, right? Okay, let's go to the next model. So that is the advantage by multiplying factors and this successive increments or decrements. I not at all suggest you to go by a plus b plus ab by 100 even in the learning process as well, because that is not applicable for all, right? You need to figure out on the one which will satisfy for all cases. Let's go for the next question. The length and breadth of rectangular plot are increased by 20% and 50%. Find out the new area is how many times the original area. 100 is initial area. 20% increase, 120. And breadth also increases by 50%. 50% means don't add 50. 50% of 120, guys. So 50% means exactly half. So half of 120, 60, 60 increases, it becomes 180. Now final area is how many times of original area. So final area is 180. This is how many times? We don't know. Some k times of initial area 100. So 20 goes 5 times, 20 goes 9 times. Simply k equal to 9 by 5. Right? Let's move on. Last question of this video, friends. If the length of the rectangle increases by 25%, by what percent the breadth has to decrease in order to maintain the same area? We know that length of the rectangle is increases by 25%. By what percent breadth has to decrease to maintain the same area? So let us consider the area is 100%, friends. But length increases by 25%, right? So if length increases by 25%, area also increases by 25%. So what is the new area? 125%. Now what is the percentage decrease in the breadth to maintain the same area? So they don't want to increase or decrease the area. So initial area is 100, even final area should be 100%. What is the percentage change? Change in value 25 decreases from 125 to convert into percent into 100. So 25 goes 5 times, 100 by 5, 20% decrease. Now friends, there are some combinations of numbers, combination of percentage changes which will give no change. Those values are, if 20% increase, let's say length increase by 20%, if breadth decreases by 16, 2 by 3%, no change in area. If length is increases by 25%, breadth has decreased by 20% to have no change in area. If length is increases by 50%, if breadth is decreases by 33, 1 by 3%, no change in area. If length is increased by 60%, if breadth is decreases by 37.5%, then no change in area. So these are the some set of percentage equivalents which doesn't have any change in value, one increase or the decrease. So in this way, you can easily work out geometry applications with percentages. So if you learn and to how to learn more such questions, if you love and to learn to have more such questions, you can subscribe to our channel, Learn QA and LR. So we issue the best wishes for all your competitive exams. So you can subscribe to our channel and click on the bell icon to receive more such updates about our classes. So thank you so much. Keep learning, keep inspiring friends.